Hello everyone. Let's continue with our classes object-oriented programming, and this is pretty much the last of the basics. After this, we focus purely on geometry and some sort of algorithms. We'll do a project together that will take your skills to the next level. Okay, so I have my folder structure here, which says functions and then a class main, and also the person class that we made last time. So what we want to do is we want to have another class called a room. We basically stick to this classes. So we create a room and we'll do the bounding walls, roof and floor. We won't do specifications, we'll just have a user input as a curve. So we'll see more about the geometry and operations in the next sections, but let's just use a curve. We'll draw the walls and we'll draw the roof and floor. So roof and floor, and then we'll have the user input, okay, and the name of the room. Okay, so let's start. So what the first thing that we want to do is we want to have a new file, empty script, and save that as a room.py, making sure that it's in the same place as class main, same directory as class main, so that it's easy to access. Okay, so because we are going to have geometry functions, we call import Rhinoscript syntax as rs. Okay, and then we define the class room. This is an object. Okay, probably no need to have space here, and then we do a def init. Okay, self, we are going to have a name and we are going to have a curve. So we have defined the class, then we define the constructor for the class. So the class will take in two parameters. One is the name of the room and second is the input curve. So and we say that self dot name is equal to name, self dot curve is equal to curve. So with that we bind the name and the curve to this particular class. Now next we want to draw the walls of the curve, and we type self because self binds this function to this class, and let's say v is equal to, now because we want to extrude the walls first, we need a path that will, along which the curve will be extruded. So we just add a line, rs dot add line, and self dot curve, add a line that goes from 0 0 0 to 0 0 10, and then we extrude the curve. We want to have a variable self dot walls is equal to rs dot extrude curve. We got the extrude curve, and we want to extrude the curve along the walls, along the V. Okay, so with this we should be able to generate the room and get the wall. So let's just test this class right here. Class is equal to room, name can be A, and curve can be C. So I'm just going to get the input curve using rs.get object, and this will, we can just say pick here. So we'll pick the curve, and there is no error, so everything is good. So what we can do is we can say r dot draw walls. Okay, so we've drawn the wall, but we have also generated this line, and we can delete the line by saying inside this function on line 10 rs dot delete object v. So this will delete the line as soon as the curve is generated. Okay, so we have the walls now. So next, let's say we want to draw the floor. So draw floor, call it self So that to get the floor, we have to do self dot floor is equal to rs dot this is just a planar surface, so we do a add planar surface to the curve. Okay, so this should give us the floor, r dot draw floor. Okay, so we have got the floor. Okay, so now I'm going to show you how we can the reason to save the variable as a self dot floor is so that we can use it in rest of the class functions, any other function that we have. So say we want to draw a roof, that will copy the floor up to the roof level, which is at 0, 0, 10. Okay, so I'm going to use this variable to do that. So def draw roof, and this is again a self, so then the program knows that roof belongs to room, and it can access the variable self dot floor. Okay, so actually self dot roof is equal to rs dot copy object self dot floor and then 0, 0, 10. So this should draw our roof, and we call this function from outside by saying draw roof. So I just want to increase the so you can see the whole code together. Let's undo this previous one and let's run this function. Okay, so you can see that we have the roof, we have the floor. Okay, we have the roof and the floor. So now, being Rhino, I mean, because this is such a powerful tool, we can generate the solution for any surface, for any type of curve, so that makes it really useful. Okay, so the next thing that we want to do really is to be able to call this class and all its methods from a different file, from a main file, and this is mainly to preserve the modularity of code and make the code more readable and manageable. Okay, so I'll copy all these driver functions from here, and we want to call this room.py from class.main file. Okay, so I'm going to go to the end, paste the code that we just got from room.py. We also need to import room function, so from room import room. Okay, so this should work, but maybe it will give me an error, and I will show you what that error is. Oh no, you can see that there is some error that says that room object has no attribute draw floor, but it has actually drawn the floor. So this is probably because of the reset script engine. So it doesn't the Python program has a small issue here, I think, where we have to save all the files and then reset the script engine. Otherwise it throws an error, it doesn't update all the functions. So let's try it again. So I've reset the script engine, and you can see that it says Python engine reset. So reset is go to tools, reset script engine. Okay, so we'll save all the files. Okay, yeah, and you can see that there's no error anymore. So that Python script engine reset is something that we have to remember to do, otherwise the program will throw an error, and then we do it. So anyway, in this section we covered classes and how to call an object from a different file and initialize the class, and also and with that I think we covered most of the basics. We can focus on geometry, which is really the best part about Rhino. and in the next sections. So let's focus on the geometry and see what we can do with it. Thank you.